Hello everyone, a very good evening all of you, and a very warm welcome to you all to this wonderful session for HPCL practice. Are you able to hear me? Please do let me know if my audio and visual quality are fine. Can you guys properly hear me? Can you see me? Please do let me know. Myself Chandrasekhar, welcoming you all to this wonderful session where we will be practicing some beautiful questions from the So we are going to discuss some wonderful questions from the thermal engineering, including the fluid mechanics, heat transfer, and basic thermodynamics and its applications. So please do join me fast. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Vanakkam. Please get yourself settled down. Keep your pen, notebook, and calculator, and try. Without calculator, you are supposed to solve the questions. And try to maintain the time. Time management is equally important. So there are some questions, there are random questions. Few questions you will find from the fluid mechanics and mixed with the thermodynamics as well as mixed with the heat transfer. So those who are here, please do respond. Is my audio and visual quality are fine? So that we can start. I hope I am properly audible and visible to all of you. Yes, I cannot see your comments. Please write me in the comment section to mark your presence. Before I solve the questions, you should give all the questions a try, and in case of any difficulty, you can let me know through the comment section. Hi Shreyas. Good evening, welcome everybody. I hope you guys are ready. So do not forget to like, share and subscribe our Resultant YouTube channel. So Resultant is known for faculty driven platform. So do subscribe this channel so that you get the notification for all the important sessions which we will bring for you from time to time. Let us start with question number 1. I hope everyone is all charged up. So yes, the first question is about to come on your screen. But for those who are attending this session for the very first time, this is my quick introduction. My name is Chandrasekhar. I am a mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and from last 12 plus years I have been into teaching. These are my favorite subjects. If you have not joined me on the Telegram yet, please do join me on the Telegram, Mechanical by Chandrasekhar. The link is also shared for your reference. And there is a MSQ series also going on the same Resultant Gate and ESC platform, taken by Abhinav sir. So do not miss. He had already completed, na? Yes, MSQ series has already been completed. If you want to watch the recording, you can watch through our YouTube channel. And there is HPCL practice or test series we are giving you for $399, which will include the full length test, 5 full length tests, including 15 non-tech tests, 20 subject wise tests, and along with that, formula notes for all the subjects will also be provided to you, and this is an added advantage. So do purchase this test series. It will help you to improve your preparation for the HPCL exam, which is very golden opportunity. There is a question on the screen. Question number 1. The question is from the heat transfer, and more specifically it is the radiation shape factor. It is from the radiation shape factor. Yes, consider two infinitely long concentric cylinders. They are cylinders. The area of a cylinder is 2 pi RL or pi dl. Area is given by pi dl. With a diameter ratio, the cylinders are having the diameter ratio d2 by d1. d2 is the outer diameter, d1 is the inner diameter, because the ratio is 5, which is more than 1. The shape factor for the outer cylinder with itself, it means F222 will be how much? Yes. The inner cylinder is cylinder number 1, which is insulated, thermally insulated from inside. There is an outer cylinder concentric, which is having the diameter d2, which is insulated from outside. We need to find out shape factor, self shape factor for the outer cylinder. Can you let me know? Give me the answer. Give me the answer for this one. So we can call this to be enclosure. It can be considered as enclosure. The gap between the two cylinders can be considered as an enclosure. So according to enclosure theorem, F11 plus F122 is equal to 1. Similarly, F221 plus F222 will also be equal to 1. Inner surface F121 is equal to 0 because it is convex surface, isn't it? Self shape factor for a convex surface is 0. This is 0, so F122 is equal to 1. So we can write F222 is equal to 1 minus F221. And what is F221? We can say reciprocity theorem, A1 F122 is equal to A2 F221. So F221 will be equal to A1 F122 upon A2, and F122 is 1. So it is 1 minus A1 by A2. And what is A1 by A2? A1 is pi d1 L, 1 minus pi d1 into L upon pi into d2 into L. Pi getting cancelled out, L also getting cancelled out. 1 minus d1 by d2. And what is d1 by d2? Let me hide myself so that you are able to see the calculation correctly. Hi Priyanshu. What is d1 by d2? d1 by d2 is 1 by 5. So answer will be 1 minus 1 by 5. That is 4 by 5, isn't it? Or 4 by 5 means 0.8. The self shape factor of the outer cylinder is 0.8. B will be the correct answer. B will be the right answer. I hope you are able to solve the question before I solved it on the screen. Right? Let us move to the next one, theoretical question. The next one is theoretical. So what is coefficient of contraction? Bataiye. What do you know about coefficient of contraction? Coefficient of contraction is defined for the vena contracta. Whenever there is a sudden contraction, this parameter is defined to accompany the loss due to sudden contraction. The losses due to sudden contraction. And in orifice meter, there is a sudden contraction of the fluid flow. And due to sudden contraction, there is a vena contracta developed. So coefficient of contraction is the ratio of area at vena contracta to the orifice area. Whenever the fluid passes through the orifice like this, then due to inertia, the fluid particles will keep on converging. The fluid particles will keep on converging and they diverge. For some distance, they will keep on converging like this and then they diverge like this. So the minimum area is area at vena contracta. This is vena contracta. And here this area is A2, orifice area. So the ratio of area at vena contracta area of the jet at vena contracta to the area of orifice. AC by A2. Coefficient of contraction is AC by A2. Option D. No. Update raho. Update raho. What is the correct answer for this one? It is not the ratio of discharge. It is the ratio of areas. It is not the ratio of discharge. It is not regarding the head loss. It is the ratio of area. It is not the ratio of velocity. The ratio of velocity is defined as coefficient of velocity. There is a difference between coefficient of discharge, that is about the ratio of discharge. This is called as coefficient of discharge. Coefficient of discharge. This is related with coefficient of velocity. This is called as coefficient of contraction, right? Answer D is correct. Yes, D will be the correct answer. Let us move to the next one. The next question on the screen. Read the question and do let me know the answer. Again from the fluid mechanics. I want everyone to keep responding the answer. Keep on giving me the answer. Which container is having the maximum pressure at the bottom of the container? There are containers having different shapes, sizes. All the containers are having different shape and sizes. We need to find out the pressure relation between the pressure at the bottom. PA will be the pressure at the bottom of A. PB will be the pressure at the bottom of B. PC will be the pressure at the bottom of C. And PD is the pressure at the bottom. If the height of water level or the same liquid, if they are having the same liquid, if the height of the liquid is same, according to hydrostatic law, what is hydrostatic law? The variation of pressure in jet direction is constant. In case of static incompressible single fluid, the variation of pressure will be in vertical direction is given by this expression. dP by dz is constant. So P is equal to rho into G into Z. Gauge pressure. Z is the depth from the free surface. This is the free surface. So the hydrostatic law has nothing to do with the shape and size of the container. It only calculates it only considers the depth from the free surface. As long as the depth are same, then the pressure at the bottom will also be same. The pressure at the bottom will also be same. All will have the same pressure. Yes, update rao, definitely. Depends on depth. D is the correct answer. Well done, guys. Good. The next one. For maintaining high efficiency in a Pelton turbine, the value of capital D by D lies in the range of, again theoretical question. Capital D by D is known as jet ratio. M. We call it a jet ratio. Capital D is the wheel diameter, small d is the diameter of the jet. This ratio lies between, yes, the ratio lies between, it lies between 14 to 16. It lies between 14 to 16. The ratio, jet ratio is between 14 to 16. The next one, from the heat transfer. The next question. Please do write the question number also. Lumped heat transfer analysis of a solid object suddenly exposed to a fluid medium at a different temperature is valid. Lump analysis is valid when R conduction is, the thermal resistance due to conduction is very, very less compared to convective resistance. And the ratio is called as Biot number. Biot number is the ratio of conductive resistance to convective resistance, which is less than 0.1. If it is less than 0.1, then we can assume the system to be lump, a point mass. And the temperature should be taken as a constant temperature for the entire system. We can assume it as a lump, and the analysis is called as lumped system analysis. Point 1. Yes. The next one. Good. The next one again from the heat transfer. Correct. The effective temperature of a black body is 627 degrees Celsius. Determine the wavelength of maximum monochromatic emissive power. The wavelength corresponding to maximum emissive power. If you draw the diagram for emissive power versus lambda, the curve will be something like this. So this is the point of maximum emissive power, and corresponding to this we call it as lambda max. So we need to find out lambda max corresponding to this temperature. According to Wien displacement law, do you remember? According to the Wien displacement law, lambda maximum into absolute temperature is constant, and the value of constant is 2898 micrometer Kelvin. 2898 microkelvin, right? So what is the answer? Lambda max is equal to 2898 divided by absolute temperature. What is the absolute temperature? 627 plus 273, 900. So if you round off to it, 3000 upon 900, it is less than, lambda max is less than 3.33 something micrometer. It is less than 3.33. So that is how you can do the calculation. A will be the correct answer. 3.22, the nearest answer. No, it is not D. It is 3.22. It will be slightly less than 3.33. 30 by 9 or 10 by 3. Less than 10 by 3. A will be the correct answer. The next question. Yes. In a steady fluid flow, from fluid mechanics, when the fluid flow is steady, what is the steady flow? When the fluid behavior does not change with time. The identical ones are path line, the actual path traveled by the fluid particle is called its path line. Streamline, the path of the entire flow is called as streamline. It is the tangent to the velocity vector at every point in the flow field. And what is streak line? It is the locus of all the particles at a particular instant when they have passed through a fixed point. So when the fluid flow is steady, that is the standard result, path line, streak line and streamline all coincide with each other. They become identical. Option D is the correct answer. All will coincide with each other, isn't it? D will be the right answer for this one. Next one, flow separation or boundary layer separation. The question is from the boundary layer separation. Near the surface, in case of adverse pressure gradient, near the surface the fluid particles start moving in opposite direction. That is called as flow separation, and it happens in the divergent boundary. Divergent passage, separation of the flow takes place in the divergent passage when dP by dx is positive, or we can call it as adverse pressure gradient, unfavorable pressure gradient. So what is the condition of flow separation in the boundary layer? You can see it. If you take the value of du by dt, this is the velocity profile, u as a function of y. Near the surface, the slope of velocity profile is negative. So when du by dy at y is equal to 0 becomes negative, then the flow will get separated. This option A is on the verge of separation. On the verge. When du by dy is almost 0, it means the flow is on the verge of separation. When du by dy at y is equal to 0, near the surface, it is B, it is not D. Sorry, not B, it is D. When du by dy at y is equal to 0 is, negative. It is negative. B is the correct answer. B will be the correct answer. It is not D. and it is not even C. Why? Because it should be y is equal to 0 near the surface. B will be the right answer for this one. Dilip, B. B for Bombay. Yes. All the options are looking very much similar to each other, but you should take care. If y is equal to 0 is not given, then that cannot be the correct answer. This is the separated flow. When, or in terms of pressure, dp by dx should be greater than 0. That is the condition of flow separation, or that is the condition causing the flow separation. Right? So we are running the paid courses also for your GATE and ESC preparation for 26 and 25 and 26. You can, if you are interested, you can connect with our support team using the given phone number. Let us move to the next one. Next question on the screen. Quickly read the question and try to solve. And give me the answer in the comment section. Air flows over a 10-meter long plate. The length of the plate is 10 meter. The transition from laminar to turbulent flow takes place between Reynolds number of 2.5 into 10 to the power 6 and 3.6 into 10 to the power 6. Beyond this, the flow is turbulent. If the Reynolds number is lesser than this, the flow is laminar. In between these two values, the flow is in transition. Right? What is the maximum distance from the front edge of the plate? Front edge means x is equal to 0, which along which one can expect the laminar flow in the boundary layer. Up to 2.5 into 10 to the power 6, the flow is laminar, and then it will be in transition, and beyond 3.6 into 10 to the power 6, the flow is completely turbulent. So we want the flow to remain laminar. The free stream velocity is given as 30 and the kinematic viscosity is given. What is kinematic viscosity? Mu by rho is given as 1.5 into 10 to the power minus 5. So we want critical value of x. So critical value of Reynolds number is 2.5 into 10 to the power 6, isn't it? So u infinity into critical value of x upon kinematic viscosity is 2.5 into 10 to the power 6. You can find out xcr. You should use 2.5 into 10 to the power 6. You are not supposed to use 3.6 because that is for turbulent. So 2.5 into 10 to the power 6 multiplied by kinematic viscosity, that is 1.5 into 10 to the power minus 5, divide by u infinity. क्या होगा u infinity? 30. Can you solve it? So it will be, that will get cancelled out. 2.5 into 10, 25 into 1.5 divided by 30. How much is that? Are you getting it as 1.25? Is it 1.25 or not? Check the calculation. It will be 1.25. Yes. The next one, from the heat transfer, there are three very large parallel plates, three plates of same area. The area is same, are kept parallel and close to each other. They are kept parallel and close to each other. They are considered as the ideal black bodies and have very high thermal conductivities. The first and the third plate are maintained at 2T and 3T respectively. The temperature of the middle plate under steady state condition is, yes, can you solve it? There are three plates, 1, 2, 3. It is at 3T, it is at 2T. We need to find out the value of this temperature. Let me call it as T2, T1, T3. So heat will flow from 3.2 to 3.2 towards 2T. The direction of heat flow will be this. from first place towards third plate, 1, 2 and 3, Q, and the mode of heat transfer is radiation. So Q radiation is equal to sigma into T1 to the power 4 minus T2 to the power 4 should be equal to sigma T2 to the power 4 minus T3 to the power 4 remains constant. Sigma getting cancelled out. So 3T to the power 4 minus T2 to the power 4 is equal to T2 to the power 4 minus T3, that is 2T to the power 4. Isn't it? So it is 81T to the power 4 minus T2 to the power 4 is equal to T2 to the power 4 minus 16 T to the power 4. So this T2 to the power 4 will go in this side. So twice of T2 to the power 4 is equal to 81 plus 16 into T to the power 4. Or we can say that will be equal to 97 T to the power 4. So T2 to the power 4 is equal to 97 T to the power 4 divided by 2. So if we want to find out T2, then 97 by 2 to the power 1 by 4 into T will be your answer. 97 by 2 to the power 1 by 4 into T. That is the correct answer. Isn't it C? Shreyas, is it C or B? It is option C. It will not be option B. Do you understand it? Option C will be the right answer. Correct? Clear to everyone? Any doubt? You can just let me know. These are our support numbers. If you want to discuss anything regarding your preparation, if you want to inquire about our paid courses, fee structure, etc., you can always connect with the given contact number, WhatsApp number or email ID. The next one is from the thermal engineering, thermodynamics. Simple question. The equation P plus A by V square into V minus B is equal to RT. This equation is called, what this equation is known? This is not an ideal gas equation. Ideal gas equation is PV is equal to RT. That is the ideal gas equation. And there are 4 Maxwell equations. This is not the Maxwell equation. We call it as van der Waals equation, isn't it? This equation is called as van der Waals equations. Next one, again thermodynamics. For a diesel cycle, what is a diesel cycle? It is also known as constant pressure cycle. In diesel cycle, there are 2 isentropic processes. One is isentropic compression, another is isentropic expansion. Then there will be one isobaric heat addition and there is one isochoric heat rejection. Isobaric means constant pressure, isochoric means constant volume. So this is diesel cycle. The compression ratio is 21 R. The value of R is 21. The cutoff ratio RC is equal to 3. What is the compression ratio? V1 by V2. The volume of the gas before compression to the volume after compression. What is cutoff ratio? Cutoff ratio is the volume after heat addition to volume before heat addition. V3 by V2. What will be the expansion ratio? What is expansion ratio? The volume after expansion V4 divided by V3. So we need to find out the expansion ratio. For a diesel cycle, compression ratio is the product of cutoff ratio and expansion ratio. So expansion ratio is equal to R by RC. That will give you the answer, simple formula base. What is R? 21 divided by RC, that is 3, 7. B will be the correct answer. 21 by 3, B. B is the right answer for this one. The next, give it a try. Solve the next question and let me know the answer. Work output need to be calculated. Work output in kilojoule per cycle. It is a single cycle. So what will be the work output in terms of kilojoule in that particular cycle, which is shown on PV diagram. So work is equal to area enclosed by PV curve. The net work output is equal to, if it is a cycle, thermodynamic cycle, so area enclosed by the cycle will be net work output. Because it is a triangle, so we can say net work output is equal to half into base. This will be the base, 1.5 minus 1 and multiplied by height. It is in meter cube, multiplied by height is 450 minus 200, and that is in kilopascal. So kilopascal multiplied by meter cube will be kilojoule. So half into 0.5 into 250 kilojoule will be the answer. Yes. What will be the correct answer? Do the calculation and let me know. Are you getting 62.5 or not? 62.5. It will be 125. 125 by 2. 62.5 kilojoule. Yes, B is the answer. 62.5 will be the correct answer. Which of the following cycles have unequal expansion and compression strokes? Stirling cycle is having two isothermal process and two isochoric. Joule cycle, also called as Brayton cycle, two isentropic and two isobaric. Ericsson cycle, two isothermal and two isobaric. Atkinson cycle is the one, it is having 6 processes, which is having unequal, expansion and compression. So it is having 6 processes. How? There are two isentropic, there are two isobaric, and there are two isochoric. So B will be the correct answer. You should remember it, that Atkinson cycle is the one which is having unequal compression and expansion stroke. Atkinson cycle is having shorter compression and longer expansion. Compression stroke is shorter and it is having longer expansion stroke. Shorter compression and longer expansion. The next question. What is the speed of sound in neon gas? It is monoatomic. Neon is monoatomic at a temperature of 500 Kelvin. Speed of the sound. C, speed of the sound is given by under root of K by rho, and K is given by Ka is given by bulk modulus is given by gamma times of pressure. Gamma times of pressure K. So it will be under root of gamma P by rho, and P by rho is RT. So C is equal to under root of gamma RT will be the expression. C is equal to under root of gamma RT. So gamma is 1.67, gamma 5 by 3, then R is given, gas constant of neon is given as 0.4210 kilojoule per kg Kelvin. It is in kilojoule. So in joule it will be 421 into temperature is 500. You need to solve this. Can you solve it without using the calculator? So this point can be removed. We can say 167 into 421 into 5. 167 is almost 169 and it is 13 square. It is close to 13 square. So 13 can be taken outside, under root of 421 into 5. Isn't it? And 421 into 5 is under root of 2105. 2105. So it is greater than 40 square. 40 square is, sorry, 2000. 40 square is 1600 and 50 square is 2500. So it is somewhere in between. 50 square is equal to 2500. So this value is somewhere between 40 and 50. So let me call it as 13 into 45 something. It is something around 13 into 45. How much is that? 45 into 13? 585. It is close to 585. 592 will be the correct answer. 592 will be the right answer. If you see 45 square, if you check 45 square, the value of 45 square is it is somewhere between 45 and 46. So 13 into 45 is 585 and 13 into 46 is 598. So somewhere it lies between 585 and 598. 592 will be the correct answer. The next one, again from the thermodynamics, the pressure and volume V of an ideal gas of mass M changes by delta P and delta V respectively during an adiabatic process. It is an adiabatic, Q is equal to 0. The value of delta V by V is given by. For an adiabatic process, we say PV to the power gamma is constant, yes or no? If we differentiate this, then we can say P is taken constant, gamma into V to the power gamma minus 1 into dV. First term, keep the first term constant and differentiate the second term, plus keep the second term constant and differentiation of the first term is equal to the right hand side is differentiation of constant will be 0. So from here we can say P into, we can write P into gamma into V to the power gamma upon V. Gamma minus 1 is V to the power gamma upon V into dV is equal to minus V to the power gamma into dP. Yes, this V to the power gamma getting cancelled out with this. So we are interested in dV by V or delta V by V, that is equal to dV by V is equal to minus of gamma by P into dP. Isn't it? Minus gamma dP by P. So option A will be the right answer for this. A will be the correct answer. Clear? This was the question given to you as an assignment in the previous class. Look, what is the question? Let us solve this one. A reversible thermodynamic device operates between the temperature limits of 500 Kelvin, 1100 Kelvin and 300 Kelvin and produces 1000 kilojoule of work if it absorbs 500 kilojoule of heat from a thermal reservoir at 500 Kelvin. There is a reservoir at 500 Kelvin and this is the cycle or an engine. It is taking the heat 500 kilojoule from here and find the heat exchange with the 300 Kelvin reservoir. This is, let us say, 1100 and this is, let us say, 300. So if we assume this is, let us say, Q1, if we assume Q2 and then it is rejected like this, let me draw like this. If the value of any Q will be coming out to be, this is, let us say, 300, it is rejecting the heat Q3 at 300 Kelvin and the work produced is 1000 kilojoule. Work produced will be 1000 kilojoule. So we need to find out the heat exchange with 300 kilojoule Kelvin reservoir. This Q3 is to be calculated. There are two unknowns, Q2 and Q3. So from the first law of thermodynamics, we can say, from the first law, energy conservation law, we can say Q1 plus Q2 must be equal to W plus Q3, yes or no? So Q3 is equal to Q1 plus Q2, 500 plus Q2 minus 1000. So Q3 is equal to Q2 minus 500. Q3 is equal to Q2 minus 500. That is equation number 1. This was 500, this was 1000 and this was the diagram. This was Q1, that is 500 kilojoule. This is Q2 unknown. This is Q3 and it is rejected at 300 Kelvin and the work produced is 1000 kilojoule. That is what is. So now if we apply the Clausius inequality, if we use the Clausius inequality, cyclic integration of del Q by T is equal to 0 for a reversible cycle. Because the cycle is given as reversible, so cyclic integration of del Q by T is equal to 0. So that means heat is added to the engine at 500 Kelvin. So that is positive. Heat added to the system is positive. This is our system. Heat added to the system is taken as positive. So it will be 500 divided by 500 plus Q2 is also getting added upon 1000. Is it 1000 kya? Yes, 1000 kilojoule and 1100 Kelvin. It is at 1100 Kelvin. 1100. So Q2 by 1100 is equal to or minus, we can write minus Q3 because heat is rejected upon 300 is equal to 0. So Q3 by 300 is equal to 1 plus Q2 by 1100. Solve it. If you multiply, then Q3 is equal to 300 plus Q2 by 3 Q2 by 11. Yes or no? Q3 is equal to 300 plus 3 Q2 by 11. There are two equations. There are two equations in Q3 and there are two unknowns. By solving these two equations, 1 and 2, you will get the value of Q3. You will get the value of Q3 to be, if you will do the calculation correctly, then you will get the value of Q3 to be 600 and this will be positive 600 kilojoule. It means heat is rejected. If Q3 is positive, then the direction is correct. The assumed direction is correct. So it means the heat will be rejected from the cyclic device to 300 Kelvin reservoir and the value of this heat rejected is 600 kilojoule. So 600 kilojoule of heat is rejected by the cyclic device. The next one, the wet bulb depression. It is used in psychrometry the wet bulb depression is equal to dBT means dry bulb temperature, WBT is wet bulb temperature, and dPT is dew point temperature. Wet bulb depression is the difference between the dry bulb temperature and wet bulb temperature. Option A. It is option A. More is the wet bulb depression, more will be the dry air, because the wet bulb temperature, the wet bulb depression is more when the wet bulb temperature is less. It means humidity is less. And for saturated condition, wet bulb temperature is equal to 0. For saturated condition, dry bulb temperature is equal to wet bulb temperature, and wet bulb depression is equal to 0. ज्वाइनिंग की बात कर रहे हैं जिग्नेश, द ज्वाइनिंग ऑफ एनटीपीसी, the NTPC will only be telling you about the joining and all. The next one, again from the thermodynamics, in a reaction turbine, the enthalpy drop in a stage. What is a stage? This is a set of fixed and moving blades. It is one set of fixed and moving blade is one stage, is 45 units. The enthalpy drop in moving blades is 23 units. What is the degree of reaction? Degree of reaction is the ratio of enthalpy drop in the moving blade to the total enthalpy drop in a stage. This is the formula for degree of reaction. So it is directly formula based, 23 upon 45 will be the answer. So it is slightly greater than 1 by 2, isn't it? It is slightly greater than 0.5. It will be slightly greater than 0.5. Point 511 is the correct answer. The next one, a heat engine receives 1000 kilojoule of heat and produces 600 kilojoule of work. The heat added to the engine is 1000 and the work produced is 600 kilojoule. The amount of heat rejected in kilojoule, what will be Q2? That is equal to Q1 minus W, and the efficiency in percentage, Q1 minus W. So 1000 minus 600, 400 kilojoule will be heat rejected. And what is the thermal efficiency? W upon heat supplied, that is 600 divided by 1000. So that is 60%. %460%. B is the correct answer. B will be the answer for this one. The next one, the cycle generally used for petrol engine, it is Otto cycle. It is an Otto cycle. Diesel cycle is used for diesel engine. Otto cycle is used for petrol engine. Option A is the correct answer. Which cycle consists of two reversible isothermal process and two isochoric? I have already told you. Isochoric means pressure constant. Sorry, isochoric is volume constant. So two isochoric and two isothermal, that is Stirling cycle. It will be Stirling cycle. What is an open system? What is an open system? An open system, there are three types of systems. Based on mass transfer, the system can be classified in three ways. If mass transfer is possible, if the mass crosses the boundary, then it is open system. Mass transfer will take place and energy transfer will also take place. One is called as closed system. Mass transfer will not be taking place, but yes, energy transfer will take place. And the third one is isolated system. Isolated, mass transfer will not be possible and energy transfer will also be impossible. So isolated. So these are the three type of system. So mass crosses the boundary as well as the energy transfer will also take place. Mass crosses the boundary but not an energy, D cannot be true. Both energy and mass crosses the boundary. C is the correct answer. Right? So this is all from my side. So I hope you guys enjoyed and you could have improved your understanding, you could have improved your concept. So prepare well for the HPCL examination. We will bring more such session for your practice. And if you are interested to be part of our paid courses, the contact details are already there in on the screen. And you can also follow us on the Instagram as well as Facebook. The QR code is already there. I will share the PDF of this session to my Telegram channel. So do join me on the Telegram if you are not part of my Telegram channel yet. So this is, there are these are our contact details for connecting with us. All right. So with this note, let me take your leave. See you in the next session. Till then, enjoy, take care, have a good day and a great career ahead.